Okay, so moving on, today we're going to be looking at the third leading cause of the decline and extinction of a species, and perhaps one of the major and most concerning drivers of biodiversity loss, which is climate change. Again, we had already established that the other two driving forces of extinction up to now have been overexploitation and habitat loss. Today we're going to be looking at climate change. So what's happening? Let's start from the beginning when we talk about climate change. So when you look at the profile of temperature over time, this is the average temperature of the planet. You can see that it was relatively stable, but in the last 5 decades or so, the temperature has been going up. Right, the temperature is increasing. You can see the trend here of increase, and this is again just the global average. And there is data like this documented for many places around the world. Here is another example, and this is from Utah. Somebody put a thermometer there since the 1500s, one of the longest records on temperature, and you can see how over time temperature remains stable, and in the last few decades the temperature just skyrocketed there. Here is another example, and again you can see this goes a lot longer though. This goes back to the 1400s, and you can see despite the fact that there has been an incredible amount of time since then, you can see that the temperature has been stable until the last few decades when the temperature went up. So something is going on. The planet is getting hotter, and now thermometers that have been put in places around the world are all confirming this trend that the planet is getting hotter. Here you can see this is the summary of all of the temperature records, and is here documented on this red background, right? So this is the average for North America, and in black is the average, and in red is the range. And you can see that in North America the planet is getting hotter. In South America the planet is getting hotter. In Europe the temperature is getting hotter. So it's in Africa, Asia, and Australia. Again, almost everywhere where we look, the temperature is getting hotter. Now the question is why? All right, so let's break down the causes of why will the planet get hotter. One possibility relates to the distance from the planet to the sun. We know that at the end of the day, the temperature of the planet is regulated by the source of energy that we get from the sun. So when you look at what could influence the position of the planet in relationship to the sun, it turns out that there are several attributes that could actually modify that distance, and as a result lead to changes in temperature. One of those attributes of the planet is what is called the tilt. Right? So we know that the planet is tilted on an angle of about 23.4 degrees. This tilting of the planet and the movement of the planet around the sun is one of the attributes that leads to what we normally call the seasons, right? So in this case, if the planet is tilted on this inclination, and that's the distance from the sun, you can expect then summer to be in the northern hemisphere. When the planet goes around the sun, now summer is in the southern hemisphere. So you can see how this tilt of the planet Earth in relationship to the sun is one of the variables that influence the seasons, and again is a major source of variation of temperature for planet Earth. The other attribute that modifies temperature is what is called eccentricity. So the way in which the planet moves around the sun is not a perfect circular. It's not a perfect circle, and in fact there is an eccentricity to it, and it's measured with this attribute that is called eccentricity, and the actual value is 0.017. By the way, just for you to know, that eccentricity is regulated by the position of the planet in relationship to larger planets in our solar system, mostly Jupiter and Saturn. These planets there are so huge that the magnetic force pulls the planet towards them. So anytime that we get lined up with those planets, our planet gets farther away from the sun. As a result, we get colder, and that obviously makes the eccentricity much narrower in relationship to the sun. When we move away from those planets, then is the gravity of the sun that pulls us closer to the planet. So you can see how we're just like being pulled back and forth and away from the sun in relationship to those planets there. Again, the magnetic force of those planets is so huge that at times they pull our planet, making it colder because we become farther away from the sun. The other one is what is called axial precision. So you guys know that we rotate in this axis here, and that rotation of that axis allows to be in position to the sun every 24 hours on average. That's what creates day and night, and you appreciate the changes in temperature that you get from that. It turns out that this movement of us moving around, there is a wobbling to that. That's how a US senator called it. And that wobbling is what is called axial precision. And again, it's not perfect. It changes from time to time. So all of these attributes, again, of the geometry of the planet in relationship to the sun is what influenced the seasons. But it turns out that over longer time periods, it creates what is called ice ages, and in what is called Milankovitch cycles. It was a pattern described back in the 76. I was only 1 year old when this paper was written, pointing out that there are variations to these geometrical attributes that lead to ice ages, to the ice ages there. Basically, what happens is this, for instance, this tilt of inclination of the planet that, as I explained to you, determines the summer, the winter or summer, changes between 22.1 all the way up to 24.5. Basically, there are times that we are much closer to the sun, and times when the still is more vertical, then the northern hemisphere is farther from the sun, so we get colder. The eccentricity also changes, and here is the range of eccentricity, and it changes on the order of every 400,000 years. And again, it's just because that's the few chances that we are lining up with these big other planets. And this actual precision changes between those numbers that you see there, and the time in which they take to change is in the order of 26,000 years. So I want you to again look at this one paper pointing out, yes, the geometry of the planet in relationship to the sun influences temperature. In the case of the tilt, there is indeed a variation that happens every 41,000 years. The position of the planet in relationship to other planets also changes the distance from the sun, and that happens on the order of every 400,000 years. And the eccentricity also changes on the order of every 26,000 years. So I want you to pause this video and think whether this is a possibility to explain the recent change that we see in temperature. Can these variables that I just explained here, the position of the planet in relationship to the sun, be the driving force on this recent increase of temperature that we see? Pause the video for a moment, think about it, and let's see what the answer really is. So I hope that your answer was no. This cannot be one of the driving forces for this increase of temperature that we see. Despite the fact that the geometry can change indeed temperature quite dramatically, this cannot be the reason for the recent increase that we see in temperature. And the best evidence that we had for that is the timing in which this is happening. When you look at the increase that we see in temperature, you can see that the profile shows that it's in the last 50 years or so that the planet is getting hotter, the last decade or the last few decades. But this changes in geometry happen on the order of 41,000 years, 400,000 years, and 26,000 years. So the time periods, the time scales at which these changes is way too slow to explain the changes that we see today. So we can rule out this possibility to explain the increase in temperature that we see today. The other factor that also influences the temperature of the planet is what is called solar flares. These solar flares are basically massive explosions, bursts of energy produced in the sun, and they eventually go in all directions, and they produce about 6 times the amount of energy that normally is produced by the sun, 6 times. But what is intriguing about this is the time that it takes for those solar flares to get the energy of those solar flares to go to our planet. It's estimated that they only take about 8 minutes to get to our planet. Keep in mind, I think I explained this in one of my first lectures, the planet is also protected with this magnetic shield that diverts most of the strong energy that comes from this. But there are times when we get hit by these solar flares that they cause not only some increases in temperature, but some electromagnetic changes that kind of ruin a lot of electronic devices. Now, these ones, though, this excess of energy that again can also affect temperature happens in the order of every 8 minutes. That's the time that it takes from there to get here. But what is intriguing, though, is that they are not quite often. They don't happen quite often. In fact, the last one that it was big that we have record of, they happened in the 1860s, right? So, and not only, again, it happened way too far ago, and they take too short, right? So again, despite the fact that these solar flares could modify the temperature of the planet, they just happen way too fast for them to explain this increase in temperature. So we can also rule out the existence of solar flares as one of the reasons for why our planet is getting hotter. That brings me to the third likely reason or factor that could explain the warming, and that relates to greenhouse gases. So we know that in our atmosphere, we had a combination of greenhouse gases, everything from water vapor to carbon dioxide, methane. Those gases occur naturally in our planet, and actually, thanks to those gases, is that life is possible in this planet. If we didn't have those gases in our atmosphere, our planet will be frozen like a popsicle, because basically all of the energy that will come from the sun will escape to outer space, and we will be frozen. So the fact that we had those gases, they were like a blanket that allows to retain some of the heat that comes from the sun. The way that those gases work is like this. So as you guys know, we are pretty far away from the sun. As a result, the only energy that managed to come from the sun to planet Earth is what is called short waves, right? And short waves can travel long distances, and those are the only energy that manage to get from the sun to us. Now, because it's short wave, that energy can go right through the atmosphere. When it bounces back, though, that energy changes wave to now what is called long wave. The analogy that I give is this: imagine that you take a gun and you shoot it against a wall. Okay, so the speed at which that bullet hits the wall is much faster than the speed at which the bullet bounces back. So the same physics happen here. There is waves in short wave coming at very high speed. They hit the ground of the planet. They bounce back. But when they bounce back, they bounce back at a much slower speed, what is called now long wave. As a result, some of that energy gets trapped by the same gases that allow that energy in the first place to come in. Some of that energy again gets trapped, and some of that energy escapes to the outer space. Unfortunately, when we start increasing the concentration of greenhouse gases in the atmosphere, the magnitude of that energy that is bouncing back is retained within our atmosphere, and that leads to warming. Now, again, here you can see again one example. This is from one of the IPCC reports, the profile of temperature from around the world. This is empirical data, and you can see that the temperature is going up. And one of the things that you can observe is the increasing greenhouse gases, or the time period that the planet is heating up, and you can see that it matches almost perfectly the increase in CO2 that we had. So this is again one of the correlative evidence that we had that this increase in temperature is better defined by the same increase that we see in greenhouse gases. Not only we know that the greenhouse gases are going up, we also know where those greenhouse gases are coming from. We know different aspects of our human life, from energy supply, transport, the construction to build our houses, industries, agriculture. We know the different contributions of greenhouse gases from those different sectors. So we, again, not only know that the greenhouse gases are going up, we know exactly where those greenhouse gases come from. So here, these are now actual simulations, right? So these are what are called Earth system models. And basically what they do, this is people from around the world trying to simulate temperature based on climatic conditions. What you see in red here is the actual temperature. And what you see in blue is simulations of Earth system models removing the CO2 from the equations. And those Earth system models manage to predict very well the actual temperature. But here in the last few decades, you can see that departure between models with CO2 and models without the CO2. And again, now what we are getting into is more predictive models pointing out that indeed this planet is getting hotter, because whenever we run these models without the greenhouse gases included, you get the blue line here, the blue area, which is again the planet remaining at the temperature that it has always been. But when we add the CO2 into those models, the temperature of the planet goes up. And again, this is again an example that allows to explain that greenhouse gases is the driving force of warming on every continent. Now, is it for real though? Unfortunately, scientifically, there is a lot of good evidence to suggest that this is the best explanation that we have for this, right? there's a possibility that maybe something that we haven't seen, but it's just very unlikely that for that to be the case. We have been studying the physics of climate change for over 3 decades now, and our degree of certainty is already to the point that many scientists are claiming that this is it, man. Unfortunately, there is a detachment between what a scientist has been studying to what the general public is realizing for this, and unfortunately it's because of there is an interface there that seems to be detached, right, between what the scientists know and what the general public know. So there is some degree of uncertainty, but it's not in the science, it's on the general public, and unfortunately it's being created by political groups. So let me just break down to you this connection that is there between the scientific reality on this and what the public actually understands for this. So let's go through the process here.
You know you're in trouble when you're being spoofed on YouTube.
Making up data the old hard way, fudging the numbers day by day.
The subject of the spoof is Michael Mann of Penn State University, who was accused of tampering with climate data to produce his famous hockey stick graph, which shows that the rise in man-made greenhouse gases corresponds to a rise in world temperatures. An academic board today cleared Mann, saying his science holds up, but the damage may have already been done. The biggest splash these days in the global warming argument may not be caused by the world's melting glaciers. It may be caused by a series of gaffes by climate change scientists. The latest one involves temperature data from weather stations in China used in global warming calculations. The problem is that where weather stations are matters. One located in the city will give a consistently higher temperature reading than one out in the country. The allegation is that the researchers used Chinese data when they didn't really know where their weather stations were. It's just a small part, they say, of a worldwide database, but it's the little mistakes that matter. Mistakes like the line in the last report by the UN panel on climate change, which claimed glaciers in the Himalayas might disappear by the year 2035. The panel had to admit the claim was wrong, and the climate change skeptics jumped in.
Any scientist that read that 2035 figure just laughed because they knew it couldn't be true. There's no doubt the trust in the UN panel has been undermined.
Trust was already undermined by the series of leaked emails at Britain's University of East Anglia, one of the world's big climate science centers, which seemed to show that inconvenient facts were being hidden. It's a frustrating time for those who believe the basic science in global warming remains true.
I am concerned that it appears the whole edifice has been undermined by these couple of bricks that are flaking a bit.
And that's a danger.
It is a danger. Oh, I totally agree.
The scientists may still believe they're winning the scientific argument, but they're in danger of losing the public relations war. Mark Phillips, CBS News, London.
Okay, so let me just give you a little bit of background on this. So there are thousands of scientists. We're not talking about tens or hundreds. We're talking about thousands of scientists around the world working on this story of climate change. And there is this consensus among all of them independently that climate change is real, is happening, and is having consequences. And unfortunately, there have been a few efforts like that one. They're called the IPCC report. And this effort, basically what it tries to do is to concatenate all of that knowledge in a single book, and they do that every 5 years. So this book comes to be easily 5,000 pages long. I don't think anyone has read that report in full because it's loaded. This is like a Bible of how thick it is, and every single page is loaded with different evidence to point out that climate change is real. We're talking about thousands of scientific papers going to that report. Out of that report, in the history of it, there have been about 3 mistakes. I'm talking about 3 mistakes out of thousands, tens of thousands of pieces of evidence that have been there. And unfortunately, those few mistakes have been the focus of most of the attention. And the problem of that is that by us focusing on five mistakes out of 10,000 of facts, we have been driving public opinion away from the bigger reality. And unfortunately, again, what is happening is that we have been the target of interest groups that are kind of trying to deceive our understanding to the general public. And unfortunately, again, as I explained to you, these human errors are being used also by public interest, including politicians. Let's just look at this one. This one I find very interesting.
The issue of global warming has been politicized. I think there are a substantial number of scientists who have manipulated data so that they will have dollars rolling into their projects. And I think we're seeing it almost weekly or even daily. Scientists who are coming forward and questioning the original idea that man-made global warming is what is causing the climate to change. Yes, our climate's changed. They've been changing for ever since the Earth was formed. But I do not buy into that a group of scientists who have, in some cases, found to be manipulating this information. And the cost to the country and to the world of implementing these anti-carbon programs is in the billions, if not trillions of dollars at the end of the day. And I don't think, from my perspective, that I want America to be engaged in spending that much money on still a scientific theory that has not been proven, and from my perspective, is more and more being put into question.
So there again, you can see the ramifications of those very few errors that are made. Is the fact that they are used by interest groups and politicians. By the way, that guy that just spoke there is Rick Perry, and he went to become the energy secretary under Donald Trump. Can you imagine a guy who is in complete denial of the science, regulating the companies that are triggering all of these things in the first place? And again, the problem is that is being used to create public skepticism. So these errors, unfortunately, are leading to public skepticism. But what is remarkable is that at times, even when we fix the errors, the damage is already done. Let's just look at, again, another interesting case example.
There's a lot of dispute, the right-wing claims over climate change. And so a great majority of the scientists in the world, in fact, 97% of the scientists that are in that field, say that climate change is real and man-made. But there are 3% of scientists, and some of them funded by right-wing groups, and some not, that are still skeptics. In fact, one of the biggest skeptics is Richard Muller. Now, he's a physicist at the University of California at Berkeley. And so he's fairly well respected, but he's a guy who is, like a lot of scientists, very, very skeptical about everything, and certainly about climate change. In fact, he said that Al Gore in the past has been, quote, an exaggerator, and he has said that the information and the facts presented by the other climate change scientists, he's not convinced by. Look, it could go either way. It could be that he's getting funded to say this, or it could be that he's just an uber skeptic, like our own Dave Kohler is a scientist, and he's the most skeptical person in the world, also about, the effects of climate change, etc. So it could go either way. And in fact, what Professor Muller did was he formed a Berkeley Earth Surface Temperature Project to make sure that he got the other scientists in check, that he was going to check all their work and double down on those projects to see if the Earth was in fact warming, because he was very skeptical. When the Koch brothers found out about this, they were ecstatic. So the Koch Foundation gave this project, the BEST project, a $150,000 grant. They said, basically, go get him, okay? And he did. And in fact, it turns out, I got to be honest with you, his scientific study turned out to be, let's put it this way, it's hard to say what's more accurate, but it has more certainty. The uncertainty in the other projects before was about 0.13 degrees Celsius. His uncertainty was 0.04 degrees, meaning that since he had accumulated all this data into one place, these numbers are actually more certain. Okay, so funded by Koch brothers, he's a skeptic to begin with, and it turns out his numbers are more certain. So let's find out what he concluded. Well, it turns out he says that the global average land temperature in the 20th century went up 0.73 degrees Celsius. Now, when they say per century, it means it measured out over 100 years. In this case, it was. In the other numbers, you'll see it's over a shorter time period. But wait a minute. That means that the temperature did go up. So there is global warming. Well, look, maybe it's just the normal variation, because a lot of the people who believe in climate change say that the Earth is getting warmer and warmer as we go along. So let's go to Professor Muller's other numbers, and probably it'll show that that's not the case. So if you look at the last 50 years, per century, it is going up 0.91 degrees Celsius. Wait a minute, that seems like it's getting warmer. Okay, but look, if you look at the last 40 years, it's probably not going to get warmer. There's probably variability, etc. So let's look at those numbers. Well, you look at that. Went up 2.76 degrees Celsius. Significantly warmer. Well, how about from 1998 to 2010, all this time, people are, Al Gore's out there saying, hey, you know what, climate change, all these other scientists, etc. NASA's concluding, my God, this is definitely happening. But all the global warming deniers are out there saying, no, absolutely not, it's 50-50, it's 50-50. So Professor Muller, the skeptic in the first place, funded by Koch Industries, must have showed that in that time period it did not get warmer. Went up 2.84 degrees Celsius. Again, per century means if measured out over the whole century for that time period, okay? So, overall conclusion, we definitely have global warming. And Dr. Muller says, my bad, my mistake. You guys were right. It turns out there is global warming. In fact, here's one of the quotes from the study. Quote, our biggest surprise was that the new results agreed so closely with the warming values published previously by other teams in the US and the UK. Oops. In other words,
I regret it. I'm sorry. You're saying I'm sorry. That was just my mistake and my bad. I'm sorry.
I'm sure that the Koch brothers will come out next and say,
oh my God, I am totally sorry for that.
Probably not, but I love that their money got used to show how incredibly wrong they were. And by the way, credit to Professor Muller, who turns out is a real scientist, did the studies, looked at the actual numbers and said, yeah, turns out they were wrong, they were right, and I was wrong to be a skeptic.
So right there, you can see most of the reality when it comes down to climate change. Again, there is an incredible body of knowledge that this is happening. Mistakes have been made, like we are all humans, and it has led to an incredible skepticism that it shouldn't be a reflection of the amount of information that is there. Unfortunately, it's being used by interest groups to exaggerate the degree of the problems. And again, even at times when we manage to fix those problems, the damage is already done. And it's kind of sad because once all that destruction is happening, all what that people had to say is, again, as that guy pointed out there, oops, sorry, I screwed up. Well, unfortunately, you're screwing up a big thing that we already know very well. This is a table, again, one of the things that I told you is never use too many letters on slides, but I'm violating my own rule here because this is an important table that came out from the IPCC report, that report that I told you concatenates all of the knowledge about climate change, and they do it every 5 years. And in this one table, they document the degree of warming and how that degree of warming influences different aspects of human life and of the planet. So you can see how warming influences water, ecosystems, food, coast, and human health. And again, that was back in 2011. The understanding now is much more severe as we have come to really appreciate firsthand what climate change is doing, not only to ecosystems, but to species. So again, just to summarize that the IPCC has a very nice report pointing out all of these different ramifications of that warming that we see in different aspects of our planet. What about on a species, though? This class is mostly focusing on a species. Well, it turns out that with this increase with this modification of the climate, mostly temperature, we are also changing the oceans, and that has consequences on biodiversity at different levels. So we already know that biodiversity can be summarized on the number of species on a place, the body size of those species, and the abundance. So those are attributes of biodiversity that we already know. Let's look now what climate change does to every one of these aspects. Let's look at species richness. First, we know for a fact that the number of species increases as you increase the area that is suitable for a species. So with these changes in temperature that we also saw earlier, temperature is one of the driving forces on determining the distribution of a species. So with this warming, what you are doing is reducing the suitability of habitats where a species can survive. And it has been found that the warming that we are seeing is shrinking the habitats of a species to the point that easily between 15 to 37% of the species of birds alone could be at risk of extinction. This is a paper in Nature by Professor Thomas there. Easily, again, when you look at all of the species together, between 20 and 40% of them, and this is again just one variable, which is temperature, leading at risk of extinction. On the oceans, coral reefs could lose up to 80% of their diversity. Coral reefs are one of the most vulnerable ecosystems to these climatic changes because, unfortunately, these species had tolerance thresholds very close to current temperatures. So when you increase the temperature just by a little bit, these coral reefs suffer quite a lot. 80% of the coral reefs today are at risk of extinction. 41% of the reef fish are at risk of extinction. So you can see that the consequence of climate change via changes in temperature on species richness is quite dramatic. Now, another consequence of these changes in climate is on the body size. Everything else the same. When you increase temperature, it turns out that the energy that you require is larger, right? You can see that, for instance, when you go for a run and when you get hot, you start sweating, and basically what the body there is doing is kind of using a lot of energy. As a result of this increasing demand of energy, as you increase temperature, species are forced to reduce their body size, right? So you are going to require more energy, but the amount of resources that you have remain the same. And a consequence of that is that the body size of the species gets smaller. Here is an example, and there are hundreds of examples, and they were summarized all on this one paper here, showing that just 2 degrees of warming increase the body size of a species between 3 and 22%. And here you can see an example of a photograph of a frog back in 1980, and just as recent as 2008, you can see the shrinkage of these species. Species are becoming smaller because of climate change, again related to the use of energy. In the last class, 2 classes ago, we saw how when the species become smaller, they produce fewer offspring that are less capable of surviving. So you can see the consequences here of the species reducing their body size as a consequence of climate change. Now, the other consequence of these climatic changes is on the abundance of a species. Unfortunately, there are some optimum temperatures and conditions where a species will reproduce, right? Who would like to have sex on a place that is super hot? Well, it's the same deal for a species. So many species don't reproduce on conditions that are excessively hot. As a result, you reduce the input of individuals to those populations when it gets hotter. There are also another consequence of climate change on a species is related to what is called phenological chips. This is a paper published by Professor Camilo Mora. And what they have been showing, what it has been found is that species are reproducing earlier. This is a pattern that is found in frogs, in birds, and even in plants. Some species that migrate also are getting to the places that they are supposed to get earlier, right? So the species are kind of being tricked by these climatic changes, and the species are getting to places that they are supposed to get earlier. And it's again a pattern that has been found on a lot of species that migrate. Now, I want you to pause this video for a moment and think about what could that mean for a species, right? If all what they are doing is just arriving a few days earlier to a place or reproducing earlier, what is that a big deal? What can that do to the species? So pause the video and think about the answer to that question again. What will it mean for a species to get earlier to a place or to start reproducing earlier? So the consequence of these phenotypic changes, phenological chips, what is called phenological chips, is that a species through evolutionary time had tailor those processes to coincide with extra supply of resources, right? So when you get a migratory bird getting to a given place, they are accounting with certain excess of food to be there on those places. The same thing goes with reproduction. Through evolutionary history, species reproduce during times when they know the amount of energy is going to be higher. So when they reproduce earlier, but the food doesn't come until later on, there is a period of time when they just don't have enough resources to survive. It has been found, for instance, that on migratory birds, the fact that they arrive to places earlier where the food is not ready for them and they move on, these species don't manage to get to the places that they need to go, and unfortunately they fail to reproduce, producing fewer offspring. So all of these migratory birds animals are suffering the consequences of these phenological chips, again, because they fail to reproduce. The same thing goes here with reproducing earlier. Sometimes by reproducing earlier, they don't manage to capitalize on the excess of food, and 2 or 3 days is already a lot. So again, these phenological changes are massive. Of all of the species that we had data for, it has been found that 62% of the species that had been studied had some type of a phenological change. Again, either reproducing sooner or arriving to places sooner. 62% of those species. Now, the other consequence of climate change that has been observed is that many species are moving up north, right? And we had examples of species now found at higher latitudes where they were never found. It has been found that on average, the species that are moving at a rate of about 6 kilometers per decade towards the poles. Again, mostly because there are suitable conditions now for species up north. Another pattern that has been observed related to climate change is that some species are moving deeper. So suitable temperatures, colder temperature, can be found at high latitudes, but in the oceans they can also be found deeper. So a lot of species have been found to be moving at deeper parts of the oceans just to be able to cope with this excess of heat that they face at the surface. Going back here to these geographical changes on the distribution of species, for instance, this paper by Professor Camilo Parmesan shows that over the last 40 years, species have been moving from 200 kilometers all the way up to 1,000 kilometers already. There is this paper by William Chung from UBC pointing out that when you analyze these changes on a species moving to places and going extinct on places, it's going to create a turnover on the distribution of species in the oceans. He found that that turnover could easily influence 60% of the species. So basically what we are doing is there are species that manage to get already where they can be with these climatic changes. The species, we are shuffling the distribution of a species to the point that 60% of the species right now could be potentially facing these changes on their distribution as a consequence of climate change. This is a paper by Professor Ulf Hock Goldberg. I hope that I pronounced his name correctly. He's a good friend of mine, a colleague of mine in Australia. And in this one paper, Professor Ulf with Bruno published a paper in Science where they compile all of the evidence of how ecosystems are changing to temperature, and they summarized all of that data in these figures here. You can see here on the y-axis temperature, and you can see different attributes of different ecosystems. So this is phytoplankton. So you can see phytoplankton declining when you increase temperature. Here you can see the total biomass, the amount of food that we can get from the oceans declining as you increase temperature. So plankton is going up. So some species of zooplankton are getting up mostly because they are probably reproducing as a result of there not being fish that will eat them as well. So here is an interesting interaction between the effects of warming and overfishing as well. Basically, the consequence of this, again, is that almost everywhere there climate change and this warming that we are seeing has consequences on a species. One aspect of biodiversity that I found remarkable is the fact that the warming is making the larvae of the fish to grow faster, right? So as a result, these species of fish in the oceans need some time to get to other places. This is what we talked earlier about metapopulations, right? So the individuals are produced on reefs and they need some time to get somewhere else. With the warming, these larvae that are put in the water grow faster, and basically they have to settle down faster. So one of the consequences of climate change is that it's reducing the time that species have to get to places, and that now is truncating what we call immigration, because basically species are not getting to the places that they can be as well. So this is an interesting consequence of climate change as it relates to species in the oceans. What about people? So it turns out that when you start heating up the air increases the capacity to hold water, right? So not only is hot, but the air can contain water. A consequence of that is that the water that is in the soil evaporates faster. And the consequence of that is drought. So drought is one ramification of these climatic changes that we are seeing. And here is the headlines of one drought event, but in this map, I point out different drought events around the world. You can see that there are multiple drought events related again to this increasing of temperature coming from greenhouse gases. Now, when there is not enough water now in the soil to evaporate, the heat that comes from the sun has nowhere to go. So you as a result of this, you get what is called a heat wave. And here is just the headline of a heat wave, but these heat waves that have been related to climate change are found everywhere around the world. And here I point out some of the heat waves there. Now, when you get dryness, it's pretty dry, and you get a heat wave, obviously what you do is to create the prime conditions for you to create wildfires. Now wildfires are so massive that you can see them from outer space. Just for you to realize that the wildfires from California produces smoke that travel all the way up to New York, just for you to realize the magnitude and the sizes of these wildfires. And these wildfires linked to climate change have been linked everywhere, and I point them out here on this map. Now, in places that are humid, this same evaporation means that a lot of water is going to go up. If a lot of water goes up, that means a lot of water comes down. And basically what is happening as a consequence of climate change as well is this massive, these very extreme precipitation events. And I point out some of them here. Now, unfortunately, when that water comes down on places that are already saturated with water. So there is an additional consequence of extreme precipitation, which is floods. And again, floods are happening everywhere around the world linked to climate change. In the oceans, it has been found as well that when we start warming up the oceans, we add a speed to the hurricanes, and we also add water to those hurricanes. So as a consequence of climate change, as a consequence of climate change, these hurricanes are becoming faster. We go from a category 1 to a category 3. And in addition to that, these hurricanes are now also carrying a lot more water. And hurricanes that have been linked to climate change have been reported everywhere. So here I just point out to you what is unintended consequences of us producing greenhouse gases mean to the climate system. Basically, we're modifying multiple climatic hazards that had consequences to people, and that's happening, as you can see from this map, everywhere around the world. So what? These things are changing. These things have been around for a long time. So what does that mean for people? So we did a paper that we published in 2014 or 15, I don't remember anymore. But basically what we did is this. Okay, so we know that we're producing greenhouse gases. First ramification of increasing the greenhouse gases is that the temperature is going to go up. And when you increase temperature, you are obviously going to increase drought, that is going to trigger heat waves, that is going to trigger wildfires. And in some other places, you are going to enhance evaporation that leads to floods and storms. And you are also increasing sea level rise. So what we did on this paper is we took all of these different climatic hazards, and then we look at how these things could influence aspects of human health, how it could influence food, water, economy, infrastructure, and security. So basically what we did was to look through the literature to find out how every one of these climatic hazards will influence these different aspects of human life. The amount of evidence that we found was overblowing to me. Here is an example. This one hurricane, again related to climate change, reported to about 30,000 cases of cholera and 30,000 cases of malaria. So here we had an example in which storms are causing an increase in diseases. Here's another example in which this hurricane killed on the order of 1,000 people. So in this case, we are talking about storms causing direct death. Death was also possible via different mechanisms. Like in this case example, for instance, we had a heat wave that killed on the order of 22,000 to 45,000 people. In this case, we had heat waves leading to death. This one, in this case, is drought causing the loss of livelihoods for people. So you can see here, drought causing the loss of livelihoods to people, and these farmers are becoming so stressed out that they commit suicide. In some places in the United States, in Australia and India and Pakistan, these countries that rely a lot on agriculture, there is so many people committing suicide from this that now there are actual programs to help farmers to cope with the stress that comes from them losing their livelihoods because the conditions just are so dry that they cannot grow their crops. This is another example again here. This is actual changes in the oceans, the warming of the oceans, preventing water to get into the mainland, leading to drought that then influences agriculture. So here we have changes in the oceans having a consequence on the capacity of the planet to produce food. This one, in which heat waves are killing cows on the order of 30,000 cows a week as a result of heat waves. So again, in this case, we have heat waves affecting the capacity of producing food via livestock. This one, again, people creating hurricanes, destroying the capacity of governments to operate. People that is in jail right now, and there is a hurricane that paralyzes everything. People ended up stuck in jail for a long time. People losing their cases. So again, in this case, we had storms creating a social, affecting social order. In this one here, drought, reducing the levels of water such that now they cannot produce electricity. So here we have drought affecting infrastructure, the capacity of us to produce electricity. This one is interesting. These are floods now influencing the cost of insurances. The cost of insurances are also influenced by storms. We found that in many of these tropical areas that are being impacted by these massive hurricanes, the cost of insurance has become so high that it becomes forbidden now for people to buy land there. Actually, insurance companies are not providing insurance to landowners on these places. So meaning that you gotta be a billionaire to buy those lands there because you cannot have an insurance on those places. But again, here is just again another example in which these climatic changes will influence different aspects of human life. This one is another example here in which sea level rise is actually causing the intrusion of salt water into water reservoirs so that now we don't have fresh water for us to drink. This one is also another one that I found very interesting. This is heat waves influencing the capacity for us to move around. During heat waves, planes cannot fly. The reason being the air becomes less dense, so the planes cannot support themselves in the air. So there are times when the heat waves get to be too strong that planes are told to stay on the ground because they can just simply not take off. We found like this 27 aspects of human health, 10 aspects of food, 5 aspects of water, 16 aspects of the economy, 21 aspects of infrastructure, and 11 aspects of human security. In total, we found over 3,000 cases in which these climatic changes are already influencing humanity. Basically, what we are talking about here is that these climatic changes have the capacity to make people sick, hungry, thirsty, poor, homeless, and unsafe. So almost every aspect of humanity can be influenced because of these greenhouse gases. And that's the reason why so many people is concerned about these greenhouse gases and why so much attention has been paid to it. And imagine if this is what it means for people and we have the capacity to withstand, you can imagine what that means for a species where they just don't have the capacity that we have. What does it mean for Hawaii? Just for you to realize, there is a very nice report done by Sea Grant Hawaii, and they documented all of the climatic changes that are happening in Hawaii. Here on this simulation, for instance, you can see the consequences of just one of the scenarios of sea level rise by the end of the 2100. For Hawaii, on the area of the Waikiki alone, we could easily lose on the order of $2 billion a year because of the floodings that we will face on that area there. So for Hawaii, there has been multiple changes that had already been observed, and those changes are projected to get even worse. And again, I invite you to check out the report that was done in Sea Grant. But all of these climatic changes, what it means for us on these islands is that they have the capacity to influence food, housing, jobs, health, and water. Almost every aspect of the quality of human life can be influenced by these climatic changes. This report was so massive and so shocking that the title of it was Climate Change Could Ruin Hawaii. It was in the Huffington Post. And again, just the title alone just highlights what it could mean for island states, these climatic changes, because seriously, every aspect of human life can be influenced by this. What is in the future though? The future looks like a lot worse. So here you can see the future projections of greenhouse gases. So this is where we are on this black line here. We actually haven't warmed up the planet by that much, only 1 degree. According to the speed at which we are producing greenhouse gases, we could potentially double or triple the effects that we see today. So all of these massive hurricanes, wildfires, heat waves that you see today, multiply them by 3, and that could be what the future will look like for us.
If the world warms by 6 degrees, from a distance, the oceans may appear bright blue, but they are marine wastelands. Deserts march across continents like conquering armies. Natural disasters become common events. Some of the world's great cities are flooded and abandoned. This could be our world plus 6 degrees.
Warmings of 6 degrees over longer time periods have been associated with some of the most devastating mass extinctions which have ever taken place. So it's certainly fair to assume that if temperatures soar by 6 degrees within less than a century, that we're going to face nothing less than a global wipeout.
6 degrees of warming has been called the doomsday scenario. Our lives would never be the same again.
So let's finish up the class there for today. And again, what I want you to realize is that there are multiple drivers to explain this decline that we see in a species, and climate change is by far one of the strongest ones. If you guys recall, when we look at the extinction chapter, how one of the mass extinction events that has been the strongest of all of them was the Great Dying Extinction Event number 3. That mass extinction event was caused by climate change, and again related to the increased emission of greenhouse gases, probably coming from volcanoes and methane that was released from the seafloor. What we are talking about here is trying to replicate almost exactly what did happen on that mass extinction event. It was the same trigger, which was warming, and we are doing it right now. And not only that, we know that we are doing it, and the evidence is pretty massive. And unfortunately, there has been some controversy, but that controversy has been focused on very small details, errors that have been made out of thousands of facts that exist about how serious climate change is. Let's finish up the class there for today.